This is mathheals.com, where you can find more links to math YouTube videos and computer science. Let's take a look at rectangular coordinates and graphs of equations. And clear up the tablet here. There we go. If you remember the rectangular coordinate system, we have our x-axis and we have our y-axis. Here in the middle is our origin. And if we I'm going to show one problem on plot points, but other than that I really hate plotting points. If you remember, like if you had 1, 2 for plotting points. This is your x part of your point, this is your y part of your point, so you go 1 for on your x and 2 on your y, and this would be your point. Presumably you've seen plotting points enough where I'm not going to go into any more detail than that. Let's take a look at graphing. Our first one is y is equal to x. Go over my graphing calculator here, and I'm going to press y equals. I'll press clear to clear out whatever's in that line, and then we'll do x. And then I'll push the graph button. And that'll give us our graph. Now all the graphs I'm going to show you here, well most of them, are basic building blocks or show you some important concept you need to know for graphing on a TA3, TA4. Now let's say your graph doesn't look like this. You got an error. Let's take a look at how to fix graph mode on TI-83, 84. First thing we do is unhighlight plot 1, plot 2, and plot 3. And what do I mean by that? Well, if you press y equals, see across the top it says plot 1, plot 2, and plot 3. Let me up arrow and highlight plot 1 and push enter on it. Let me down arrow. Now if we press graph, sometimes it'll work, sometimes we'll get an error. This time it worked. The different errors you might get, it might say invalid dim. Other things it might do is it might put extra boxes on your screen. Let me go up here and highlight one of these other ones. I'm just up arrowing and right arrowing and pressing enter on that to highlight it. There's my invalid dim one. So if you press graph, it says invalid dim. You just do enter and quit, and you go back to y equals, and again you don't want any of these highlighted. So if you got any of them highlighted, press your up arrow and your right arrow if necessary. Put your flashing cursor on whichever one's highlighted and push enter one time. That'll take the highlighting off. I'm going to right arrow over to plot 2 and I'll press enter on it. Take the highlighting off that. So that's the first thing. Can't have anything highlighted on plot 1, plot 2, and plot 3. Our second item is to clear out y1 through y0. You'll notice on the left here we got y1, y2, so forth. If I down arrow, you'll see it goes down to y0. Assuming I can actually click the button. There we go. Occasionally, people get garbage on here. They'll get some real weird stuff, like this. And then when they push graph, it works, and it's like, okay, there it is, and boom, syntax error. And it's just like, well, that's great. No, this was easy as can be, he said in class, and why am I getting a syntax error? Well, notice quit's highlighted. If you go to install some software, each box that pops up, you read it very carefully. The user agreement, you read every word. No, what do? You click next as fast as you can. Well, on a calculator, your typical thing you do is just, well, go ahead and press enter. So, okay, well, let me go look at it. You look at it, you don't see anything wrong. So, well, that's weird. Let me try it again. And you get another error. What you should do, and what they should have put first, is they should have put the go to first. If I down arrow to the go to and press enter, this is so cool. It takes you where the problem is. And I can see I have garbage down here. So then you just press clear to clear that out, and then you back up and running. Now, I used to, when I'd have students have this happen, I'd say, well, do you have kids? And some of them say yes. I said, well, don't let your kids play with the calculator anymore. And then some people would say, well, no, I don't have any children. And I'd tell them to quit drinking while they're using their calculator. But then somebody, a few semesters back, said another possibility. They said, I throw my calculator in my backpack without a cover on it. I don't know if they lost their cover or they just, what they do exactly. And while it's in their backpack, the buttons are getting pushed, weird buttons. So I guess there's a third possibility besides kids and alcoholism. So those are the first two items. Our third one is press zoom and choose Z standard. So if you're seeing something weird, here's your zoom button. You press that, and then you see Z standards are 6 1. So I'll down arrow to it. Now I'm gonna press enter on it. Now you can also press the number that's in front of it. See the 6? If you press the 6, it down arrows for you and does the enter for you. So it's kind of a shorthand way of doing that. Now those three things, if you get those all fixed, that probably will fix about 99.5% of the problems. There's a few other oddball ones that happen, but those are the majority of what happens. Majority of what goes wrong, I should say. Okay, let's look at this one. I got y is equal to x squared. And trying to shut down my PS3. There it goes. Okay. It's kind of roaring. In case you're wondering what that is, I don't got a jet airplane in the backyard. I just got my PS3 running. There, it's off. Let's take a look at y is equal to x squared. Again, this is another basic building block. Anytime you do graphing, it usually revolves around what I'm showing you here. So x squared. Well, if I press y equals, press clear, I'll do the x key, and you see there's a button here that says x squared. Now that doesn't put the x on there for you. You have to do that yourself. But if you push the x squared, it puts a squared on there, and then you push graph. And that'd be your answer. Our next one. Y is equal to x to the third. Now this, I could care less what x to the third looks like. We're showing here, how do you put in any number? Because you could have x to the fourth, x to the fifth, and so forth. This case is x to the third. So I'll come over here. I'm going to show you two different ways for doing this. I'll press y equals. I'll press clear. I'm going to do my x key, and I'll push my caret, and then I'll put 3. And then graph. And that'll give us our graph. I said I was going to show you another way. If I press mode, and some of you can't do this, so if you come here and it doesn't look anything like it, then don't panic or anything. If I down arrow, you see how there's a math print on my second page? My flashing cursor is on math print. I'm going to go ahead and press enter on it. I'm going to do a second mode to exit out. Okay. So I'll press y equals. Press clear. Now when I do an X, and now when I do a caret, it throws it up in exponent mode, which is kind of nice, but it's also something extra you have to do, so that's why I wanted to show it. So if I put 3 in, there's my third power. Well, you have to be sure you press your right arrow key before you start doing anything else. So if I want +1 or whatever, make sure you do a right arrow key to take it out of exponent mode. And if you press graph, you get the same graph. Now I'm going to set my calculator back. I'll kind of flip back a little bit on each one just so you see the differences. Again, I press mode. I'm going to down arrow to that math print. And I'm going to set it to classic. So I right arrowed over to classic, put my flashing cursor on it, press enter. And I'll do second mode exit out. Second mode exits you out of anything on your calculator. Okay, let's look at this one. Y is equal to x to the 1/2. Now, there's nothing special about the exponent here. Caret is how you put an exponent into your when you got an exponent. But in this one, if you have more than a single number or single variable in your exponent, you have to put parentheses around it. So when I plug this one in, I want to put parentheses around the exponent. Okay, so I'm going to press my y equals, clear, and I do x caret, beginning parentheses, 1 divided by 2, closing parentheses, and then graph. And that would be our sketch of our graph. Okay. Now, the newer calculator. Let me show it. I'm going to press mode. I get more and more students come in with the newer one. And if you want yours to look like what I'm going to show in class, if you're actually in one of my classes, then come here and make sure it just says classic. Then it'll look exactly like what I'm showing in class. I'm going to press enter on math print. Now let me go back to y equals. Okay, so press y equals, press clear. Now when I do an x, it does a caret. Again, it throws it up in exponent mode. So I do 1 divided by 2. And to get out of exponent mode, you just do your right arrow key. So nothing special there. And then graph. Now, if you're sitting there trying to switch this back and forth between math print and classic, if you don't got a newer TI-84, you got an older TI-84 plus, it will not work on, so don't even try it. So press mode. And keep going down. There we go. I'm going to set this back to classic. And exit out, second mode. That was number 4, I think. Now, I wasn't really showing how to do x to the 1/2. I could care less about this. But how do you do it when you got any fraction in your exponent? Or if you have even something more than that. If you had something like this. Y is equal to x to the x squared minus 2. How do you graph that? Well, we actually know everything we need to know to graph that now. If I come back here, press y equals, press clear, I do my x key, caret. Whenever you have more than a single number or a single variable in your exponent, you put parentheses around it. So I'll put beginning parentheses, x squared, minus 2, closing parentheses, and then graph. And that would be our graph right there. A little bit different. Okay. Let's look at our fifth type. This is the square root of x. Should have saw this at the tail end of elementary algebra. Okay, so I'll press y equals, press clear. Now above the buttons you see in my calculator here it's blue. I think it's yellow on a TI-83. I'm just doing this from memory. So I see above the x squared there's a square root symbol. So to get to it, I press second button one time and then push the x squared. Put the X in, put a closing parentheses. Closing parentheses are actually optional on a TA3, TA4. And then graph. And we get the same graph as the last one, which is no surprise because y is equal to x to 1/2. X to 1/2, we're going to see later on in this course, is the same as the square root of x. Next one should be the cube root. Well, I'm going to press my y equals. Press my clear. Now, if it's not on a button, it's not above a button, then it's probably underneath your math button for graphing purposes. So I'm going to press my graph button, or my math button. And you see the cube root is the fourth one down. So I'll press number 4 to quickly choose it. And then I'll put an X key, and then I'll push my closing parentheses, and then graph. And that's our answer. Okay, so let's look at our next one. This is the fourth root. I could care less what the fourth root looks like. What I'm showing here is how do you handle it when you have any number in here? If you have a 5, you have a 6, you have a 7, you have a 201. That's that little number that's in here we'll see later on. It's called the index, the number in a slot. Now to do this on the calculator, this is the one they screwed up on. I'll press y equals, press clear. It says we put our 4 in first. And now we're going to go into the math menu. And you see the one with the radical symbol with the X on it, number 5. We want to choose this one. Now it doesn't put a beginning parentheses for us, so we have to put a beginning parentheses ourselves. Every other function for graphing purposes that you'll find on TI3, TI4 will put a beginning parentheses. That's one of the features they added to it. I forget which model it was that didn't have the beginning parentheses, but they had people come and say, hey, we're getting tired of pressing this beginning parentheses because it should always be there. Well, they fixed all of them except for this one. So you have to put beginning parentheses, then X, and then closing parentheses. And then I push graph. It looks like the square root, but it's a little closer to the x-axis. Like that. Let me start a new page. Now this one, if you didn't put the beginning parentheses and just put a single X, it would actually work. The only one that'll actually work on, though, is when you have a single X. If you have anything else inside the radical, it won't work. So you should just get in the habit of when you have the fourth root, fifth root, when you have to use this function, always put a beginning parentheses. Now, of course, if you're using the newer TI4, when you choose this, it puts it under a radical symbol, and it's pretty nice. The key thing to remember when it writes a radical there, let me show what it looks like. Press mode and down arrow, and got math print. Now if I press y equals, notice how it does the radical symbol here. We'll talk more about radicals later on in this course, but the key is that if I'm sitting here underneath the radical, to get it out of the radical you have to press your right arrow key. Now, see, I think if I start typing now, it's still underneath the radical. So if I press my right arrow key one more time, then as I start typing, it's not under the radical anymore. So, something to keep in mind. Let me go back to my mode and set this back. I wish they wouldn't actually make changes like that. Kind of bothers me. And choose classic, and then second mode. Not that I'm stuck in the past, but it's just like make your changes to the newer models TI Inspire and so forth. Don't change this, because then it gets confusing. Half students have it this form, half of them have it in this form. So, okay. Let's take a look at the absolute value of x. This one's kind of hidden a little bit. I'll press y equals, press clear. Now it's not on a button, it's not above a button, so it's underneath math button. If I press math, but it's nowhere here to be found. So what I do is I right arrow over to num, and you see ABS is already highlighted, so I press enter on it. Put in my X key and closing parentheses if I want. Closing parentheses is very end or optional. And then we press graph. And that would be your answer. Now this next one is just an example. It shows you how to plug in a fraction into your calculator. And we're graphing it. And the key is, if you got more than a single number or single variable in top or the bottom of your fraction, you want to put parentheses around it. Well, we got more than a single number or single variable on top, so we had to put parentheses around that. And we also have it in the bottom here. So when we plug it in, we have to put parentheses around the top, parentheses around the bottom. Other than that, you type it in exactly as you see it. So press my y equals, press clear, beginning parentheses, x plus 2, closing parentheses, divided by, beginning parentheses, x minus 3. Closing parentheses, and then graph. And this would be your answer. So we got didn't go down that far, but anyway, close enough. Now, the reason why even sketching, I mean, you can see it on the calculator much better than what I can draw, is on a T83, it'll put an extra vertical line here. It won't be in red, but it'll just be an extra vertical line. That is a flaw with the calculator. That is not a feature. They're not putting something called a vertical asymptote on there for you, which we'll see in college algebra. They described it. I went to the TI's website and read it. The programming was such that they like plot points, and then when they go to connect them together, they come down here, and the computer doesn't pick up its pen and comes up here, just draws straight up, and then continues, like an etch sketch. That's how the website explained it. I was wondering myself, because I thought I was wondering why I did that. If it was a feature, or it turned out to be a flaw. Anyway, on a TI-3, don't put the vertical line. You should never have vertical lines in your graphs in this class. Now the next thing in this talks about intercepts. Let's talk about intercept. An x-intercept is where it touches or crosses the x-axis. And our y-intercept is where it touches or crosses the y-axis. Okay, so for number 10, the x-intercept. I see it crosses at 4. So our x-intercept is 4. Now if we want to write that in point form, that would be 4, 0. Now our y-intercept is where it touches or crosses the y-axis, which is 3. Or if you want to write it in point form, that'd be 0, 3. And those would be your answers. Let's look at this one. X-intercept crosses at negative 4, 1, and 3. So negative 4, 1, or 3. Negative 4, 1, or 3. If I write them in point form, that would be negative 4, 0, 1, 0, and 3, 0. And then our y-intercept looks like it's 12. Or if you want that in point form, that'd be 0, 12. Now that's technically the end of the section, but I wanted to show you one by plotting points. I hate plotting points. But let me get it out of the way. Okay. What I'm going to do is I'm going to build a t-chart. And so let me put in 1, 2, and 3. So if I plug in 1 for the x, I'm going to have 1 squared, or 1. If I plug in 2, I got 2 squared, or 4. If I plug in 3 squared, I'm going to have 9. So we plot points. 1, 1. 2, 4. 3, 9. And that'd be our answer right there. Or would it? Remember what y is equal to x squared looked like? Excuse me. It looked like this, didn't it? I just didn't plot enough points. So let's put 0 in. Negative 1, negative 2. So 0 squared is 0. Negative 1 squared is positive 1. Negative 2 squared is equal to 4. 1, 2, 3, 4, like that. So here and there. And now be our graph. The problem with plotting points is what I just deliberately pointed out here, is you have to know what the graph looks like before you even begin in a lot of cases, as your problem becomes harder. Now if you're just talking about a line, that's one thing. But as you get further up in math, they don't always follow a linear form, so you have to know what it looks like. Well, if you already know what it looks like, why are you even graphing it? Here's the example I always give. Let's say I'm the best point plotter there ever was in elementary algebra. Everybody else was happy with like 10 or everybody else was happy with 1 or 2 points. I had to do like 10. So here we got our graph, and it's this one right here. Or is it? Maybe this is our graph. We just didn't plot enough points to get that picture. Maybe our graph goes up like this and comes back down over here at x is equal to 1,000. Now in intermediate algebra, college algebra, we're just concerned mainly with our standard viewing window, from negative 10 to 10 on the x and y. So even in intermediate algebra and college algebra, you wouldn't see this point. But if I stuck with plotting points all my life, I would have to plot 1,000 points before I'd see it actually come back down. And maybe this isn't 1,000, maybe it's 1,000,000. So I'd have to plot 1,000,000 points in my t-chart before I actually saw it come back down. Now, again, in intermediate algebra, college algebra, we're happy with the standard viewing window for the most part. We'll see a few techniques in college algebra help you see something if it comes back down. And calculus is where you learn the techniques to get what is a true picture of the graph. But again, plotting points is not a great way. Use technology. You don't want to be stuck back in the 1800s. Nobody's going to hire you. So anyway, that's the end of that section. So let me save it.